Students, and screen visible arka? I mean audible?
Yes, sir.
Okay, right. Right. So, good morning, students. So, welcome to module number 44 in the IC engine subject. Right. So, today we are going to see about the variable compression ratio engines. Right? That is the VCR engines. Right. So, why we require this type of ECR technology, right? So the VCR technology, that is the variable compression ratio engines, right? So the technology has long been recognized as a method for improving the fuel economy of the SI engines, right? So in the SI engines have a lower part load efficiency when compared to the diesel engines, right? So to improve this efficiency, operates on the SI engines with a high compression ratio at a part load and the low compression ratio with a high load, right? So we required the different compression ratios depending upon the load condition, right? So depending upon the efficiency and the power condition, we required the different type of the compression ratios, right? So it is a modern technology, right? It is a modern technology. So in this technology, we modified a design, we implemented or we proposed a modified design for the various engine elements, right? So especially for the crank rod, right? That is the connecting rod, right? So the connecting rod to increase or decrease, right? So it will modifies its compression ratio, right? So at the two stages, right? Either it is in the high compression ratio as well as the low compression ratio, right? So it is continuously varying, right, its compression ratios by the changing of the connecting rod distance, right? So by changing of the modification of the design in the connecting rods, and mainly with the piston is connected with the eccentric mode, right? So there we can get a different type of the compression ratios, right? So why we required this type of VCR engine means the obviously same reason, right? So we have to reduce the emission as well as we have to increase the fuel economy, right? We have to increase a good economic of the fuel, right? So the lower consumption of the fuel has to use, right? So due to that, as well as at the same time we have to get a extreme power, right? So why we have to go for the modern technologies means the three conditions, right? So one is the fuel consumption, right? So in conventional engines we are required the more amount of the fuel, right? So to get the maximum power or a power will be somewhat good, right? So the fuel economy is very important one, right? The fuel economy is very important one, and the performance of the engine and the emission, right? So these three are the very important one for the modification of modern technology which we are used in the IC engines, right? Right. So the VCR is a technology. It is to adjust the compression ratio, right? It is to adjust the compression. See, it is a technology which is adjust the compression ratio, right? So when the increase in fuel efficiency while undergoing the varying of load, right? So whether we are using a low load, that is the part load, it is called as the part load, and we are using the high load condition, right? So depending upon the load condition, surely what will happen means the compression ratio requirement is varies, right? The compression ratio requirement is varies, right? For example, you can see here, if we are using the higher loads, right, so it will require a low compression ratio, right, to be a more efficient, right? So at the same time, if we are using the low load requires the high compression ratio, it's a vice versa, right? So in this type of condition, the compression ratio has to be adjusted, right? So that type of engine technology is called the variable compression ratio engines, right? Then how we can adjust the compression ratio, right? How we can adjust the compression ratio means first of all, we have to know what is the compression ratio. What is the compression ratio, right? What's the compression ratio? The engine's maximum volume, right? It is a ratio between the engine's maximum volume and the minimum volume of the engine, that is the volumetric, right? So we have to adjust, right? We have to adjust the volume of the cylinder, right? We have to adjust the volume of the cylinder, right? So you can see the variable compression engine allows for the volume above the piston head, that is the top of the top dead center, right? Top dead center, it may be it changes, the volume may changes, right? So that we can see what is the compression ratio, right? It is the maximum amount of the cylinder, right? It is the maximum amount of the cylinder, right? Then it is compared to the minimum amount of the cylinder, right? So that ratio is called the compression ratio, right? For example, you can see, so it is our combustion chamber, and here it is a TDC position, BDC position, and the piston, and it is connected to the crank, right? So what is the maximum volume, right? So right, so from here to here, it is the maximum volume, right? So this volume, and once the piston will be compresses, once the compression stroke will be occurs, so where the piston will be located, the piston will be located at the TDC position, right? Then what about its volume, right? So once the piston will be reaches the TDC position, then what about its volume, right? So the ratio between this volume and this volume, that is the A by B, that is the maximum volume to the minimum volume, right? So it is called the compression ratio. It is called the compression ratio, right? So how we can change the compression ratio, right? So once if the A value will be increases, so what will happen? The compression ratio will be increases. If the B value will be increases, what will happen? The compression ratio will be get reduces, right? So you can see here the variable compression ratio engines allow the volume above the piston, right? Above the piston of the top dead center. So this, right, above the piston here, this area, this volume, right? So the variable compression ratio depends on this volume, most probably this volume, right? So how the volume will be changes, then what are the modifications we have to do for this condition, right? So that we can see in the VCR engines, right? So before entering this lecture, just I can put a video, right? So you can see that video, and after that video we can go through the slides, so it will be easy for you, right?
Aside from the obvious of changing compression ratio,
Whether my screen is visible
No, sir.
now? Yes. Okay, right.
Yes, sir. Yes, sir.
we'll also chat about the cylinder liner, balancing characteristics, efficiency, learn all the details about how this engine works. And there's a lot of innovation going on. Aside from the obvious of changing compression ratio, we'll also chat about the cylinder liner, balancing characteristics, efficiency characteristics, as well as some of the testing to ensure reliability.
Here you can see
So the initial question is, what's a compression ratio and why create a car with a variable compression ratio in the first place? Well, the compression ratio, or the ratio of the maximum cylinder volume to the minimum cylinder volume, can be used to create efficiency and power characteristics of an engine. Now, Infiniti wanted to design an engine that could match the power of a naturally aspirated six-cylinder engine while still achieving the efficiency and torque characteristics of smaller diesel engines, all with improved emissions. So how exactly does it work? Well, the engine operates on the same basic four strokes as any other engine: intake, compression, power, and exhaust. That said, it can completely alter the compression ratio to target increased horsepower or increased fuel economy. There are four basic steps for changing the compression ratio in this engine. First, a harmonic drive, essentially an electric motor, rotates an actuator arm. Second, the actuator arm rotates a control shaft, similar in principle to a camshaft, which forces a lower linkage to move up or down based on the orientation of the cam lobe. Third, the lower link changes the angle of the multi-link, which is connected by an upper link to the piston. Finally, the upper link moves from the multi-link's rotation, which causes the piston to move up or down, changing the compression ratio. So for
You can see the four major terms, right? So the four major terms will be changes the um, compression ratios. That once again you can see, right, what are the four terms. So the first term will be here, right? So here the first term, right?
this engine. First, a harmonic drive, essentially an electric motor, rotates an actuator arm. Second, the actuator arm rotates a control shaft, similar in principle to a camshaft, which forces a lower linkage to move up or down based on the orientation of the cam lobe. Third, the lower link changes the angle of the multi-link, which is connected by an upper link to the piston. Finally, the upper link moves from the multi-link's rotation, which causes the piston to move up or down, changing the compression ratio. So for example, if the engine was operating in its power mode, but wanted to switch to an efficiency mode, the harmonic drive as shown would rotate to the left. This would then rotate the control shaft, which would pull the lower link slightly down. This would rotate the multi-link slightly to the right, which would then force the upper link slightly upward, decreasing the space between the piston and the cylinder head, thus increasing the compression ratio. Okay, so now that we understand how it works, why would you want to switch between compression ratios? Starting with the scenario of
Whether you have seen how the how the engine volume will be changes. Anyone?
Yes, sir. Yes, sir.
Yes, yes, you can see why, because this animation helps to understand how the compression ratio will be various, right? What are the elements we have to modify in the engine, right? So that you can see clearly once again.
Now that we understand how it works, why would you want to switch between compression ratios? Starting with the scenario of creating maximum horsepower, a low compression ratio of just 8 to 1 is used. This is because the engine is turbocharged. So when you pull in significantly more air and fuel with the turbocharger, you can make significantly more power. However, the likelihood of engine knock increases. Engine knock can be destructive to an engine. However, by using lower compression ratios, you can reduce the likelihood of it occurring. So when the engine is creating its peak power of 268 horsepower or its peak torque of 287 pound-feet, it's doing so by lowering the compression ratio and maximizing boost with the turbocharger. Switching between the two extremes from a compression ratio of 8 to 1 to 14 to 1 or vice versa can happen in 1.2 seconds. So what about when the engine operates at peak efficiency at a ratio of 14 to 1? Well, generally speaking, the higher a compression ratio used, the greater the thermal efficiency of an engine is. In other words, high compression ratios mean better fuel economy. So when the engine is operating at low loads, for example when you're idling or when you're cruising down the highway, it will switch to higher compression ratios to maximize fuel economy. Now, not only does it change the compression ratio, but it also switches from a traditional engine cycle to the Atkinson cycle by altering valve timing. The Atkinson cycle leaves the intake valve open for a short duration of the compression stroke, which means some of the air-fuel mixture is pushed out of the cylinder. What this does is effectively cause the expansion ratio, the piston moving down, to be greater than the compression ratio, the piston moving up, which allows the engine to get the maximum amount of useful work out of combustion. Now, so far I've made it seem like the engine operates in two distinct modes, but in reality it's fully variable and can operate at any unique compression ratio between 8 to 1 and 14 to 1. Ultimately, the engine will choose the ideal compression ratio for the situation, depending on the driver's throttle input. If the driver is not asking for power, it will adjust the compression ratio to operate as efficiently as possible for the given gas pedal position. And the innovation with this engine doesn't end with a changing compression ratio. There are a lot of unique features. For example, inline four-cylinder engines are inherently unbalanced. That means that the engines vibrate, and so to compensate, four-cylinder engines often use balancing shafts, which add complexity and consume.
So here you can see this part, right? So due to this part only, the engine volume will be varies, right? So you can see the cam lobe, right? It is called as the cam lobe part, right? So due to this part, what will happen, the engine's volume will be varies, right? That you can see clearly. You can see.
For the given gas pedal position. And the innovation with this engine doesn't end with a changing compression ratio. There are a lot of unique features. For example, inline four-cylinder engines are inherently unbalanced. That means that the engines vibrate, and so to compensate, four-cylinder engines often use balancing shafts, which add complexity and consume power, but eliminate the vibration. The reason four-cylinder engines are unbalanced is because of the crankshaft design, which creates a secondary force that is not balanced out based on the movement of the piston. You'll notice, however, that this engine doesn't have balancing shafts, and that's because the geometry of the crankshaft assembly does not cause the piston to create a secondary imbalance. To my knowledge, there's no other inline four-cylinder engine out there that won't have secondary balancing issues without the use of balancing shafts. So not only can it change compression ratio, but it's beautifully smooth and balanced at any compression ratio it chooses. Another unique characteristic of this crankshaft linkage is that it nearly eliminates side forces from the piston on the cylinder walls. In a typical engine, a piston will have a large opposing side force on the cylinder wall as it also pushes downward, rotating the crankshaft. This is because with normal engines, the connecting rod is at a significant angle when rotating the crankshaft. This engine, however, maintains a nearly vertical connecting rod for the combustion stroke as the piston is moving downward, which eliminates the side force from combustion against the cylinder wall. With less force against the cylinder wall, there's less friction, and as the force is all in the desired direction, this is more efficient. Now, looking at the cylinder liner, you'll notice it's very shiny and reflective. This so-called mirror coating is the result of the same plasma sprayed cylinder liner that's used on the Nissan GTR. After the plasma spray is applied, there's a very fine cylinder bore honing, which ultimately leaves behind a very strong, durable, and highly reflective cylinder liner. The engine also uses both direct injection and port injection. It was found that the most efficient combustion at low loads occurred with both port and direct injection active, and this also helps to keep the valves clean.
Introducing pedigree gravy with chicken.
Correct. So you may seen how the modifications are there, right? So what are the modifications are there in the VCR engines, right? So we have the lot of modifications in the VCR engine. So for that only we can obtain the different compression ratios depending upon the load condition and the speed condition. If the load will be high, on the time we required more power, right? On the time we required more power. So how the compression ratio will be changes, right? So you can see, right? So if it is in efficiency mode, right? So for example, if you are driving a car in a city mode, in the highway mode, right? So where you can get the more efficiency in a, if the car is going on in a highway, it means we can get a good efficiency, but it is in for the city drive means it is not suitable for the high efficiency, so that we require some power, right? So for the power and the efficiency, which one is our demand, depending upon the demand condition, the compression ratio may be varies, right? The compression ratio may be varies, right? So you can see one more video, right? That's a very simple one. See where the power and efficiency when demands, right? So depending upon the demand, the compression ratio varies. note that the first device is the harmonic drive, right? So which is reduction of the gear. So it is the main part, right? So due to this part, the volumetric changes will be occurs, right? So you may remember this is the first part, that is the harmonic drive reduction gear. See, while it is in power mode, how the harmonic drive will be there? It is a turbocharger. So while it is in power condition, the compression ratio will be 8:1. If it is in economic mode, the power compression ratio will be 14:1. You can see here, so how if it is in low compression ratio, high compression ratio, the differences, right? So where the low compression ratios will be used means during the high power required, a high load required condition, we are using the low compression ratio, right? You may remember this one, right? So when the power is required, there we can use the low compression ratio, that is the 8:1 condition, right? That's then where the speed condition will be low, right? So the low load will be there, so there we can use the high compression ratio, that is the 14:1, that is the economic level, right? So it is the red color will be indicates the power mode, and the blue color will be indicates the efficiency mode, that is the economical mode, right? Right. So here you can see the harmonic drive.
சார் இப்போ எக்கனாமின்னு வச்சா ஹை கம்ப்ரஷன் ரேஷியோ வருமா சார்?
Yes.
சார் ஹை கம்ப்ரஷன் ரேஷியோ நமக்கு வந்து அப்போ எப்படி சார் எக்கனாமி வரும்? அந்த பவர் தானே சார் இருக்கும்?
இல்ல நான் சொல்றேன் லோட் கண்டிஷன்.
ஓகே சார்.
Here you can see. Right. So if it is in power mode condition, the compression ratio will be get reduces, right? So compression ratio gets reduces. You can see here, the screen is visible, right? So here you can see the low compression ratio gives the maximum power.
கம்ப்ரஷன் ரேஷியோ கம்மியா இருந்தா அது பவரா இருக்குமா சார்?
Yes. So for example, which one is the power will be more, either the petrol engine or diesel engine?
பெட்ரோல் இன்ஜின் தான் சார் பவர்.
Petrol in the power அதிகம். Okay. So compression ratio, what about the compression ratio of petrol engine, and what about the compression ratio of diesel engine?
சார் பெட்ரோல் இன்ஜின்ல வந்து ஸ்பார்க் மூலமா சார், இதுல டீசல்ல வந்து கம்ப்ரஷன் மூலமா
the ignition method is different, but what about the compression rate? Where the
டீசல் தான் சார் அதிகமா இருக்கும்.
diesel rate
அதிகமா இருக்கும் சார்.
எது
டீசல்
compression high, correct? But the power pickup அப்படின்றது எது அதிகமா இருக்கு? diesel engine.
பெட்ரோல் தான் சார் பிக்கப் அதிகமா இருக்கும்.
Petrol the pickup அதிகமா இருக்கும். That pickup is called as the power. Okay va? So the low compression ratio gives the more power. Right? So இத நான் இன்னும் clear explain பண்றேன். Class number back slide இருக்கு. நான் உங்களுக்கு clear explain பண்றேன். இப்போ இந்த basic the replay
புரிஞ்சு
ஓகேவா? ஸோ இதை ஞாபகம் வச்சுக்கோங்க. நான் இதை வச்சு உங்களுக்கு நான் மறுபடியும் நெக்ஸ்ட் கிளாஸ் வரும்போது சொல்றாரு, ரைட்டா? ஸோ ஏன் வந்து இந்த கம்ப்ரஷன் ரேஷியோ ஹை பவர் லோ பவர் இருக்கு, அந்த கண்டிஷன்ஸ் ஏன் மாறி வருதுன்றது நான் உங்களுக்கு சொல்றேன். ஓகேவா? ஸோ யூ கேன் ரிமெம்பர் திஸ் ஒன். ஸோ இஃப் இட் இஸ் இன் லோ கம்ப்ரஷன் ரேஷியோ, if it is in low compression ratio, it is in power mode, so there the compression ratio will be 8:1, right? So if it is in economic mode, right, so you are see, if it is in economic mode, here the high compression ratio will be there. So on the time the compression ratio will be 14:1, right? On the time the 14:1, right? So here you can see how the power mode and economic mode will be changes, right? How the power mode and economic mode will be changes, right? So you by using this drive, harmonic drive, right? Right. So even இப்போ வர இந்த ஸ்கூட்டி பைக்லாம் பார்த்துருக்கீங்களா, டிவிஎஸ் பைக்லாம் பார்த்துருக்கீங்களா? ஸோ இஃப் த த்ராட்டில் வில் பி மோர், நீ நிறைய கொடுக்குற அப்படின்னா நமக்கு என்ன, அந்த ஆரஞ்சு கலர் லைட் அண்ட் கிரீன் கலர் லைட் எரியும். அதை பார்த்துருக்கீங்களா பைக்ல? ரிப்ளே அன்மியூட் அண்ட் ரிப்ளே.
எஸ் சார்.
எஸ். So அப்போ உங்களுக்கு தெரியும், ரைட்டா? So if you are giving the more accelerator, ரைட்டா, so on the time power light will be blinks, correct? So if you are going by the efficiency mode, there the economic mode will be blinks, right? So on the blink ஆகுது எதை பேஸ் பண்ணி வேரி ஆகும் அப்படின்னா, so due to this harmonic drive, right? So in the harmonic drive plus the throttling range, right? So அதை பேஸ் பண்ணி நமக்கு என்ன ஆகுது, the power mode and the economic mode will be changes. Just you can see this video, after that we can discuss that one. Okay va?
Okay.
Right. So it is an important 2-mark question, right? So for the conventional engine, the sidewall force will be more. Conventional engine, the sidewall force will be more. Why? Because the crank and the connecting rod position will be varies, right? But in VCR engine, most of the connecting rod position will be in a vertical mode. So the sidewall force will be reduces on the VCR engine. It is an important 2-mark question. You may note this one. So in this diagram you can see here the red portion, red part will be there, right? Why the forces will be acting on the side walls. So here the side wall forcing is not acting, right? So that you can see. Right. It is the question, right? It is the question. So there is no sidewall force acting on the VCR engines, right? இதுதான் நமக்கு வந்து ஒரு 2-mark question, important 2-mark question. You can see there is no piston side forces will be acting on the VCR engines. Right. So ஏன் அப்படின்னா இங்க வரக்கூடிய அந்த crank shaft, right? So here you can see the crankshaft angle பாருங்க, இங்க crankshaft angle, and once it will be rotates, right? Rotate ஆகும்போது நமக்கு வந்து இந்த crank வந்து ஃபுல்லாவே நமக்கு வந்து இங்க இருந்து இது வரைக்கும் நமக்கு ஃபுல்லா ஆசிலேட் ஆகுற மாதிரி இருக்கும், கரெக்ட்டா? பட் ஹியர் பார்த்தா அப்படின்னா வந்து the crank வந்து ரொம்பவே கம்மியா தான் இருக்கும், the angle tiltation ரொம்ப கம்மியா தான் இருக்கும். So you may note that one. At the same time, here we are using the 2 types of injection, either the GDI injection also we are using, and the port fuel injection also we are using here. Right. So you may get just idea about the VCR engines, right? How the VCR engine, the compression ratio will be varies. அது உங்களுக்கு சிஸ்டமேட்டிக்கா உங்களுக்கு தெரிஞ்சா எதனால compression ratio நமக்கு வேரி ஆகுது அப்படின்றது, how the volume will be changes. கரெக்டா? ஸோ அந்த வால்யூமை பேஸ் பண்ணி தான் நமக்கு என்ன compression ratio அப்படின்றது இருக்கு. கரெக்டா? ஸோ how the compression ratio will be varies. அது தெரிஞ்சப்ப உங்களுக்கு?
Sir.
Right. So most of the compression ratio, நம்ம யூஸ் பண்ணக்கூடிய compression ratio, one is the low compression ratio and one more is the high compression ratio we are using, right? So for the low compression ratio it's around 8:1, right? And in the high compression ratio we are using 10:1 to 14:1 வரைக்கும் நம்ம maximum இது யூஸ் பண்ணிக்க முடியும், right? So compression ratio for the passenger cars, right? So காருக்கு வந்து பார்த்தீங்கன்னா நமக்கு வந்து 8:1 to 10:1 or maximum 14:1 we can use, right? So the wide ranging conditions, right? So wide range of the operating conditions will be possible in the VCR engine. That is the main characteristics of this VCR engine, right? Then the variable compression ratios, right? So at the low power level, the high compression ratio captures the fuel efficiency benefits, right? So அது நோட் பண்ணிக்கப்ப இதுதான் அந்த பாயிண்ட், right? So the low power level, right? So low power level, what will happen if it is in low power level means automatically what will happen, the fuel economy will be good, right? The fuel economy will be good, right? So there we didn't require the more power, right? There we didn't require any more power. But in high power levels, the low compression ratio prevents the knocking condition, right? So this is the main reason why we have to use at the power condition we are using only the low compression ratios. Why? Because it will prevent the knocking condition, it will prevent the detonations, right? So once if it prevents the knocking, so what will happen, the emission conditions will be good, right? So emissions எப்படி இருக்கும், somewhat it will reduce us, right? If you avoid the knocking, then it will prevent from the damaging of the engine parts, right? So that's the reason. Then the advantage of this VCR engine will be if the compression ratio will be modified, right? If the compression ratio will be modified means we can modify our power and the economic range of the fuel terms as well as the performance terms, right? Then the fuel efficiency will be increases and it will consumption will be reduced in this type of, so it will climbs, right? It will climbs up to 70% of fuel only it will climbs, right? So then the additional variable valves and the additional element, the turbochargings will improve the fuel efficiency, right? So generally the superchargers and turbochargers, why we have to use the superchargers and the turbochargers, right? It will give the more air to the combustion chamber, right? So if the more air will be gives in the combustion chamber means it will contain the more amount of the oxygen, so the fuel will be mixed with the air which is present in the combustion chamber. It will have the better mixing and the better combustion, so it will better burning also there, right? So better, due to the better combustion, the emission will be reduces. At the same time, the fuel efficiency will be increases, right? The fuel efficiency will be improves, right? And the reduction of the combustion and the reduction of the combustion emissions also we can avoid or we can reduce. So these are all the advantages and these are all the disadvantages, right? So here we are doing a lot of things, right? But anyway, the life of the engine, it's not proven, right? So the reliability of the components, right? So why? Because here you may see the VCR engine, we have the plenty of elements, right? We have different type of elements, right? So which is connected through the connecting rod, and it will be connected by one more element, and it will be connected through a crankshaft, right? So here we have the lot of elements, right? So we, in the lot of elements, we required the more reliability conditions, the life will be somewhat good. But here the life of the engine is not proven whether it is good or not, right? So it is not proven. That is a major disadvantage, right? Anyway, it is a new technology, so still the research is going on. So they will prove, right? So they will prove the life of an engine, right? So here now, at the present condition, the reliability of the components, it's not proven, right? Then the consumer reaction is unknown and unpredictable. Why? Because this VCR engines will be a limited one, right? So not it is used in all the type of the vehicles, right? So here still the research is going on. It is a very new technology, right? So it is a very new technology. At the same time, it will have the lot of the extra elements, right? So a lot of extra elements will be there in the engine components, right? So the manufacturing cost also high, right? So the manufacturing cost will be high, then the product life will be not proven, reliability is not proven. Then the consumer reaction is the unknown and unpredictable. Why? Because it is not a commercially comes into the market, right? So if we require that type of engines will be produced and it will be given to the customer, then the feedback will be somewhat not yet surveyed, right? Then the repairs and the maintenance also here, the difficulty and high. Why? Because it is a new technology, so the new technicians is required to repair, and the maintenance cost will be more. Why? Because here we are using the lot of drives, right? So simple harmonic drive will be used, and the clamp rod will be using, and the extra components will be using here, right? So it is a major disadvantage of the VCR engines, right? Then we have some more conditions, right? So that we can see in the next class, right? So up to this we can stop here in this class, right? So up to this, do you have any doubt in this class?